Questions 21 through 25 on the 2019 Grade 11 Fermat Math Contest. In the multiplication shown, each of P, Q, R, S, T is a digit. The value of P plus Q plus R plus S plus T is. Let's write this out. So the top is going to be 4 times, we have 4 plus 10T plus 100S plus 1000R plus 10,000Q and then 100,000P. And there, that is equal to this guy. And we'll expand that. So that's T plus 10S plus 100R plus 1000Q plus 10,000P plus 400,000. Okay, so now let's expand this and put it all on one side. I'll try to do that in one so that it doesn't so we save steps is what I meant to say. So the 400,000 minus this 16 is going to be 399,984. And then this 40T minus T will be 39T. And then 400S minus 10S is 390S. 4000R minus 100R is 3900R. 40,000Q minus 1,000Q is 39,000Q. And then finally, 400,000P minus 10,000P is 390,000P. Okay, so now we got to match all this up. I think P will be 1. That will fit perfectly. If P is 1, that means that's 390, so I've got to figure out this to be 399,984 minus 390, and that is 9984. Okay, so that's got to be 9984. Well, obviously 39,000 is way bigger than that, so that most likely means that the Q is 0. But this 3,900 I can fit into that. How many times at least? 2 times, I think. That's the max it'll go. So R will be 2. So now, only thing that's left is these guys. So I have to subtract from 9984 2 times that 3,900. And when I do, I get left with 2184. So that basically means that these guys have to equal 2184. Okay, so how many of these 390s can I squeeze out of there? I think 5 would be the max, so that would make S equal to 5. So that means that 39T is equal to 2184 minus 5 times 390. So 39T is, what is that, 234? So that means T is 234 divided by 39, which is 6. That works out great. So that means PQRST is 1, 0, 2, 5, and 6. And then that 4, multiply that by 4. And then it's going to give you 4 PQRST. So that's going to be 4, 1, 0, 2, 5, 6, 4. Okay, there you go. I did it. So now I have to add up all these guys. That's not a problem. P plus Q plus R plus T. That is 1 plus 0 plus 2 plus 5 plus 6 plus 4. And that is equal to, oh, sorry. Oh, not the 4. Don't make that mistake. Just those 5. And those 5 equal 14. So number 21, the answer is A. In the diagram, 2 circles touch at P. Also, QP and SU are perpendicular diameters of the larger circle that intersect at O. Point V is on QP and VP is the diameter of the smaller circle. The smaller circle intersects SU at T as shown. If QV is 9 and ST is 5, what is the sum of the lengths of the diameters of the 2 circles? Well, the first thing I would like to do is try to approximate the center of VP, the smaller circle, and I think approximately here. And I'll draw a line from there to that point T. And I think that should be it in terms of my diagram. Now I have to label. All right, so the radius of the small circle, which is from there to there, obviously, I'll just call small r. And then this is also small r, since it is from the center. I have called that the center to the edge of the circle. And then they told me that this is 5 and that this is 9. That's given in the question. And now let's see here. This is also going to be small r. But I really want to get that distance, so I don't know what it is, so I'm going to call it x for now. And then this, of course, will be big R, since this is going to be big R, the radius of the larger circle. So from here to here would be big R minus 9. And then the x, I think x is simply just big R minus small r. So x is really just big R minus small r, like that. All right, so now I think we just have to label this guy, and we have a Pythagorean relationship since this is a right angle. And from here to here is just going to be big R minus 5. So my Pythagorean relationship is big R minus 5 squared plus x squared, which is big R minus r squared, is equal to r squared. Now we have two variables in there, so if I can get a relationship between big R and small r, that would be very helpful for me. And I think I can fairly easily. The entire diameter, of course, is 2r, 2 big R. And the entire diameter can also be represented by 2r plus 9, where you have 2 small r plus 9. So there you go. I can just isolate for big R, r plus 4.5. And I think that should be good enough. So here we go. Let's expand and let's substitute. So the big R would be r plus 4.5 minus 5 all squared. And this is going to be r plus 4.5 minus r all squared is equal to r squared. So this looks like r minus 0.5 squared plus 4.5 all squared is equal to r squared. So let's expand this. So r squared minus r plus 0.25. And then 4.5 squared is what? 20.25. And then this is just r squared. Well, the r squareds cancel. And this becomes 20.5 is equal to r. All right, great. And then big R, we can calculate with this formula. It's small r plus 4.5, so that's going to be 25. Now what do they want? The sum of the lengths of the diameters of the two circles. Okay, so the diameter of this, we can call it small d, is 2 times 20.5, so that's 41. The diameter of this is big D, which is 2 times 25, which is 50. So the sum of the diameters would be the sum of those two guys, 41 plus 50, and of course that is 91. So number 22, the answer is B. How many positive integers n with n less than or equal to 100 can be expressed as the sum of 4 or more consecutive positive integers? Let's begin. First and foremost, we have to say or to describe the strategy, and that is just looking at it from the perspective of how many integers. So in the first case, it's going to be 4 because that's where we start. Sum of 4 or more consecutive positive integers. So let's say k represents how many positive integers we have. So I'm going to start with k equal to 4. So that means x plus 1 plus x plus 2 plus x plus 3 is equal to my n. So that means that 4x plus 6 is equal to n. So if I were to make a little table with x and n, and x starts at 1, then n would be 10, x is 2, n would be 14, and so on, right? You will get a whole bunch of values for x and n. So I'll just list the values for n when x is 3, n is 18, and so on. So you will get values of n, these ones 10, 14, 18, but then you'll also get 22, 26, and then it just keeps on going, right? 30. I'm just going to write in, not all of them, but just some of them to kind of illustrate somewhat of a pattern. 90, and then in the end we get the last two, which are 94 and 98. Now when you add these up, 98 is achieved when x was 23. 4 times 23 is 92 plus 6, which is 98. So there's 23 of these numbers. So what I'll do is I'll write how many of them here. We'll keep a little tally on the corner there. All right, so next is when we have 5 consecutive. When you have 5 consecutive, it'll be x plus 1 plus x plus 2 plus x plus 3 plus x plus 4. And that is, of course, equal to n. And that, when you add it up, is 5x plus 10. So in the same way, x and n, when x is 1, you get 15. When x is 2, you get 20. And so on, right? So it would be 25 and 30 and 35, all the way up until 100, actually. But here's what makes this question challenging. There's going to be doubles. The list that I just made here, some of those are already included there. So what you say is, well, is there any kind of a pattern there? And the answer is, of course, it's just going up by 5. So any multiple of 5 that's up here, I'm going to be counting twice, so I've got to eliminate those. First of all, how many do I get here before I even eliminate? Well, to get 100, x has to be 18, right? So there's 18 of these numbers. But 30, 50, 70, and 90 are included in this list as well. So those 4 I have to subtract from that 18. So it actually is going to be 18 minus 4, which is 14, of course. So now I'm going to keep a tally. 23 from here plus this 14 is now up to 37. So I'm keeping a cumulative tally. Okay, so I hope by now you kind of understand how this is going to go. It's the same thing over and over again. So 6, I'm just going to write these numbers. You don't need me to write out x plus 1, x plus 2. You understand by now. So this sum is 6x plus 15, and that is equal to n. So in a very similar way, you write x and n, and you make your list. So when it's 1, it's 21. When it's 2, it's 27, and so on. So you get all the way up as close to 100 as possible. It could include 100 also. When x is, what? Does it equal 99? Well, that's 14. When x is 14, you get a number of 99. So obviously there's going to be 14 numbers there. But as always, we have to see, did we count any doubles or triples or whatever? And the answer in this case is yes. There's going to be numbers in here that we've already counted, and those are 45 and 75. Those will have appeared up here because those are multiples of 5. So from this 14, I actually have to subtract 2. So 14 minus 2, which is of course 12. So that 12 I have to add to this 37. So my cumulative total is now 37 plus 12, which is 49. All right, let's keep going. Now we get into 7 consecutive numbers, and that sum is 7x plus 21 is equal to n. In a very similar way, you make your list. 1. When it's 1, it would be 28. When it's 2, it would be 35, I should say, and then so on. So we get all the way up, this time to 98, and that happens when x is 11. So obviously there's 11 numbers here. But again, as before, are there any doubles? And the answer is yes, there are. First, let me write out some of those guys. I'm just going to write out the ones that are doubles. 42, 63, 70. So the ones that I've already counted before, this guy, the 42, the 63, the 70, and the 98, all of these appear up here somewhere. For example, the 35 would appear in this list. this list right here. As you can clearly see, there's a 35 there, and so on. The 70s are here. The 42 would appear in this list here, and the 63, that would appear in this list. So you can list them all out and check them all out and in your practice. So from the 11, I've got to subtract 5 actually this time. So 11 minus 5, so there's only 6 unique ones. So I've got to add 6 to that. So that gives me 55 as my cumulative total. Okay, I'm getting pretty close to the answer choices, but I haven't approached them yet. And that's the time-consuming aspect of this question here. Okay, now we're up to 8 consecutive digits, or 8 consecutive numbers, I should say. So 8x plus 28 is the sum this time. And in a very similar way, you make your list, x, n. When it's 1, it would be 36. When it's 2, it would be 44, and so on. So again, ... you're going to get a bunch of numbers all the way up until 100 this time, actually. All the way to exactly 100, and that happens when x is 9. So there's 9 numbers. But again, as before, we have to figure out how many of these did we actually include before. The 100 has already been included in this list, as you can clearly see there. 60 is also going to be included already in this list, since it's a multiple of 5. And the 84 will be included also. And that 84 actually will come from that list. So from these 9, we have to subtract 3. So we have to do 9 minus 3, which is 6, and those are the unique ones. So for this 55, we have to add 6, so now we're up to 61 as our total. Okay, we are getting close. Now, 9, that sum is now 9x plus 36. And then with 9, when you make your list, x and 1, we get, when x is 1, it's 45. And then so on, right? A whole bunch of numbers here. And all the way goes up to 7. When x is 7, it becomes 99. And I'll just write them out. The 54, 63, 72, 81, and 90. So there's obviously 7 of these. And interestingly, of these, the only one that is a unique one is 72. All the other ones have already been counted before. So this one only gives 1 unique. So we add 1 to our tally, which was 61, and now we're up to 62. Okay. For 10 consecutive digits, we get 10x plus 45. And when you make your list, x and n, you get 55, and you get 65, 75, 85, and 95. And none of these are unique. And none of these 5 are unique, so you get 0. So our tally is still 62. Now we get up to 11, and for 11, the number is 11x plus 55, which is equal to n. And when you make our list here, we get 66, 77, 88, and 99 for x 1, 2, 3, 4. And of these, the only unique one is 88. All the others have appeared before. So now we have 1 unique one. We add it to the 62, and we get to 63. And the good news is, for the other ones, that's it. You won't get any more unique ones. And you can try those on your own when the number of consecutive numbers is 12 and 13. All right, so in a very painstaking way, we got the answer. Number 23 is 63, which is choice B. Consider the quadratic equation x squared minus r plus 7x plus r plus 87 is equal to 0, where r is a real number. This equation has 2 distinct real solutions x, which are both negative exactly when p is less than r, which is less than q, for some real numbers p and q. The value of p squared plus q squared is. We have x squared minus r plus 7 plus r plus 87 is equal to 0. Now, we have to find two solutions, first of all. So that means the discriminant cannot be 0, and I'll talk a little bit about that later. Both of these solutions are going to be negative. Okay, so those are some important conditions that we have to keep in mind. So let's just go ahead and do the quadratic. So that would be r plus 7 minus b plus or minus the square root of b squared, r plus 7 squared, minus 4ac. A is 1 and c is r plus 87. And that's all over 2a, but a is 1. Okay, so this is r plus 7 plus or minus. When you expand this out, you get r squared plus 14r plus 49 minus 4r minus 348. All over the square root sign, and this is all over 2. So let's see here, r plus 7 plus or minus. When you combine this, we get r squared plus 10r minus 299. Okay, so this is the discriminant right here, and I'll write it out. And I had previously mentioned the discriminant in this case has to be greater than 0. So r squared plus 10r minus 299 has to be greater than 0. If it was equal to 0, we would only get one root, and we need two roots. So let's work with that. R squared plus 10r minus 299 has to be greater than 0. So what I want to do is get an understanding of when is this graph greater than 0, for what values of r. And I think I'll be able to do that without too much problem by doing a quadratic once again. And can this factor? If it can factor, I wouldn't need to do a quadratic, and I think it can. 23 and 13, I believe. 23, 13, R, and in terms of the signs, plus for 23 and minus for 13. Okay, so let's just do a basic sketch. So that means when R is 13 and negative 23, those are the roots. And because this is a positive coefficient, it's going to open upwards. So basically the graph is something like this. Something like that, right? So that means it's above 0 when r is either greater than 13, as you can see here, or when r is less than minus 23. All right, so that's very helpful. So now what I have to do is go back to my original equation, which is right here, and try to satisfy the next condition, which is that both have to be negative, both the roots. I've looked at that and I've figured it out that there's two solutions when r is in those ranges, but now I've got to satisfy what is r in order to make both of the solutions negative. Okay, so I've got to get both of these negatives. Now I don't know, so I'm going to just pick one and see what happens. So I'm going to start with this one. R is greater than 13. Okay, let me choose r equals 14. Let's see what happens to the roots. So x would be therefore 14 plus 7 plus or minus 14 squared plus 10 times 14, 140 minus 299, all under the square root sign, all over 2. So that's going to give me 21 plus or minus, what is this? When you do the math, I think it becomes 37 over 2. And this gives me, both of these are going to be positive. One's 13.5 approximately, the other one's like 7.5 approximately. Okay, well, that didn't work. So it must mean that r is less than 23. But just to be sure, let's see. Let's choose a number that's less than 23, minus 24. And let's see what happens. So plug it back into this equation. Minus 24 plus 7 plus or minus 24 squared minus 240 minus 299, and that's all over 2. So x is going to be minus 17 plus or minus, and this becomes 37 root again, interestingly. So this gives me roots of minus 11.54 and minus 5.46. So there we go. We got two negative roots. So I am going to conclude that r is less than minus 23. All right, great. So r is less than minus 23. So this basically means that q is minus 23. I'll just write it up here. R is less than something and greater than something. Well, I just proved it's less than minus 23. So I got the value for q. Now all I have to do is figure out what is it greater than, and then I can easily figure out q squared plus p squared. How do I do that? Well, we can just use the same. We are told that these have to be negative. So all I have to do is set that less than 0. And once I do, I can get an understanding of what r is in terms of what is greater than. So let's do that. Let's just keep that in the screen. And let's set that less than 0. So r plus 7 plus or minus the square root of r squared plus 10r minus 299 all over the under the radical divided by 2, that has to be less than 0. And we had done that earlier. The only thing is we had done it for actual specific numbers. But I don't want to do it for any specific numbers. I would like to do it for just r. So here we go. Multiply through by 2 and you just get r plus 7 square root of 2 r squared 10r minus 299 is less than 0. Now at this point I'm going to compare a little bit to make it a little bit easier to understand with what I did over here. So for example, the r plus 7 is represented here by minus 17, right? So I'm just going to put that in there just so you know what's kind of happening here. And then this part, the radical, was this guy, root 37. And that has to be greater than 0, right? So continuing with the r's, what I'm going to do is put that on the other side. So r squared plus 10r minus 299 square root. So that basically means that you have this plus or minus still, but really it's still a comparison between something like minus 37 and root 37. And minus 17 is less than plus or minus root 37. If it's plus root 37, it's obviously less, and even if it's minus root 37, it would be less. Now here's the part of the question that we need to pay close attention to. I want to get rid of that radical sign. And when I do, obviously, I square both sides. When I square the right side, it just becomes r squared plus 10r minus 299. When I square the right side, that's what I get. When I square the left side, it'll be r squared plus 14r plus 49. But here's the thing. I have to switch this symbol from less than to greater than, because now, remember, I put these in for a reason to illustrate what happens. When you square, because this number was negative, it becomes 17 squared. This squared becomes 37. So as you can see, it's greater than. So that's why that sign had to be switched. Now at this point, it becomes relatively easy. The r squareds cancel from both sides. I can bring the 10r over, so this becomes 4r is greater than minus 299 divided, minus 299 subtract 49. So that gives me minus 348. Divide through by 4, and it will give me minus 348 divided by 4 is minus 87. There we go. R is greater than minus 87. So I go back, and that's exactly what I needed. I needed something that R was greater than. So R is greater than minus 87. There you go. I just got that inequality. And now they want p squared plus q squared. Well, this is my p, and this is my q. So p squared plus q squared is just minus 87 squared plus minus 23 squared. And that is equal to 8098, conveniently right underneath. So the answer to number 24 is E. In triangle QRS, point T is on QS with angle QRT equal to angle SRT. Suppose that QT is M, TS is N for some integers M and N with N greater than M, for which N plus M is a multiple of N minus M. Suppose also that the perimeter of triangle QRS is P, and that the number of possible integer values for P is M squared plus 2M minus 1. The value of N minus M is. Let's do some labeling. Let's call this side RQ equal to X, and this side RS equal to Y for now. The very first thing is I've got to label this theta and this theta. So immediately, since that line RT cuts that in half into two equal angles, I immediately think of the angle bisector theorem. And that is going to give me as follows: X over M is equal to Y over N, directly from the angle bisector theorem, no tricks at all. And then I think I'd like to put the M and the N together, so M over N is equal to X over Y. Well, if that is the case, then that's very helpful because I can call X and Y in terms of M and N. So X could be some multiple of M, and Y could be some multiple of N. As you can see, the K's would cancel and it would just give me M over N. So Y I'm going to refer to as Kn, and X I will refer to as Km. Now, we are going to use something called the triangle inequality, which I'm sure many of you know. Two sides have to be greater than the third side. So let's see here. I will compare this side and that side. So that's X and Y. So X plus Y has to be greater than the third side, which is right here, which is M plus N. And instead of putting X's and Y's, I'm going to put the Km plus the Kn values greater than M plus N. Factor out the K and you get M plus N is greater than M plus N, and that basically means that K is greater than 1. Now I will use the triangle inequality again, but this time two different sides. I will compare this plus this to be greater than the third side. So it would be X plus M plus N is greater than Y. Well, again, instead of X's, I'll put Km plus M plus N, and then instead of the Y, I'll put the Kn. So this becomes M plus N is greater than Kn minus Km, and I can factor out a K, and when I do, it will be N minus M, and I'll just bring that into the denominator. So K is greater than N minus M plus N over N minus M. All right, so that's pretty decent, I think. Now let's start talking about the perimeter, which is something they are putting a lot of emphasis on in this question. The perimeter of this triangle, just based on what we have up there, is X plus Y plus M plus N. And the perimeter in terms of K's and M's, X is Km, Y is Kn, and then this is M plus N. And I think I can factor out something. I can factor out the K. This will be M plus N. This will be M plus N. Factor out the M plus N, and I get K plus 1. All right. So now let's discuss this. We have some very helpful inequalities up here. The first one tells me that K is greater than 1. So since K is greater than 1, that means that the perimeter must be greater than M plus N times 2, because K is greater than 1, so that has to be greater than 2. So therefore the perimeter has got to be greater than 2 times M plus N. Also, another thing that we know that P is an integer. So since P is an integer, P has to be at least So greater than or equal to this plus 1. So 2 times m plus n plus 1. So for example, if this was whatever, 12, and p is greater than 12, p has to be at least 13. And that's all that is, really. Nothing too complicated. All right. Now let's talk about this inequality. Since k is less than m plus n over n minus m, that means that this can be looked at in a very kind of similar way, that's equal to p. So that means that p is less than m plus n times this. We're going to substitute for that. So it would be m plus n over n minus m, and then don't forget about that plus 1. And in a very similar way, since p is an integer, p has to be less than or equal to m plus n times that m plus n over n minus m plus 1 minus 1. So for example, if this was, say, 14 and p is less than 14, p has to be at least 14 minus 1, which is 13. So that's why we put in that negative 1 there. Okay, well, these two things, this one and this one, give me a range. Combining, it gives me a range that p is between. It's either less than this guy, p m plus n times m plus n over n minus m plus 1 all minus 1, or it's greater than this guy, which is just 2m plus n plus 1. Okay, so for example, let's say the numerical values were 50 and 25, and I asked you, they're all integers. How many values does p have? Well, they're all the integer values from 25 to 50 inclusive. So the total would be, 25, 26, 27, all those guys. And you'd easily calculate that by doing 50 minus 24. So in the same way, if I said, how many integer values are there for that range? It was the same thing. You take this and subtract from it this, and then subtract one more. Exactly how I did there. So the number of values of p would be this guy, which is m plus n times m plus n over n minus m plus 1 minus 1 minus this guy, 2, let's just put it in brackets, m plus n plus 1, and then don't forget to subtract 1. So minus 1. Exactly like I did for this right here. And then they told me that the number of values of p is equal to something. In the question, the number of possible integer values for p is this, m squared plus 2m minus 1. So that m squared plus 2m minus 1 is essentially what this whole thing is equal to. So I'll put it here. M squared plus 2m minus 1. And there you go. This is what we have to now simplify. And there you go. There's a simplification. I don't think you want to hear me go through all of this. That would be very painful. I encourage you to do this on your own, and when you do, you get to this very nice result at the very end. That 0 is equal to m times n minus m minus 4. Well, m and n represent distances, so m obviously cannot be 0. So that means that n minus m minus 4 must be equal to 0. That means n minus m is equal to 4. And that is what they wanted you to figure out, the value of n minus m. It's 4, and therefore the answer to this challenging question is A.